Hello friends, welcome to this session. Here we are going to solve JEE Main Physics Test 60 and I'm telling you it's not an easy one. It was difficult for me. Some questions had very rigorous calculation. As for me 7 are tough. These two have very tough calculations and I think 19 there's some fundamental flaw in the question. I feel the question is incorrect in some way. 4 are easy, only 1 or 2 are questions are like directly tick and move. Otherwise every question requires you to apply concepts and do calculation. Doing this in 1 hour and doing it correctly is a challenge for an average student. Again, for an average student, if he get 50 plus, he is very good. And for a good student, again, because he is a good, he has to get 70 75 plus. But believe me, this paper is not that easy. I have solved it, and from my experience I can say it's not a cakewalk for anyone. It was a tough paper. So let's start the paper. Imagine an atom made up of a proton and a hypothetical particle of double the mass of the electron but having the same charge as that of the electron. Okay, apply the Bohr-Adam model and consider all possible transition of hypothetical particle to the first excited level. The longest wavelength photon that will be emitted has wavelength lambda. Okay, so longest wavelength is from 2 to 1, plus one thing. Here the mass is double. I know that E naught that we write as 13.6 or RHC, that is proportional to the mass of electron in the expression. So here that mass is doubled, so that E naught or R is going to be doubled. So if I solve this, what we'll have now, that 1 by lambda, that is going to be what we had now. The previously we used to write it as, now RHC or R, here I will write it as 2R. That would be 2R into 1 upon what we'll have now. We'll have now what we have, the longest wavelength photon that will be emitted, 1 by 1 square minus 1 by 2 square. So that is 2R into, sorry, first excited means 3 to 2. I'm wrong here because first excited means 3 to 2, that is 1 upon 2 square minus 1 upon 3 square. So 1 upon 4 minus 1 upon 9. So what it comes out as, it comes out as 10R by 36. So lambda comes out as 3.6R, or I should write it as 18 by 5R as depicted in your option C. So go for option C, that is going to be your answer. Next. A shell in an air explodes into n equal fragments. K of the fragments reach the ground earlier than the other fragments. The acceleration subsequently will be. So now, what would be the acceleration subsequently now? K of the fragments reach earlier. So now we have n minus k, and that divided by m by n, that is the remaining mass, into m. Let's say let each mass be m and total mass we can say as nm. And these are having acceleration g, rest are having 0, so no factor for them. So now what I have is n minus k upon n times g. So this is a question that has been asked before also, maybe in JEE Main or NEET. Go for D option. Next one. Particle is given a horizontal velocity u from a point P on a smooth horizontal floor with a vertical circular track. ABC is a semicircular track of radius r. If the path length x is 3r, this which path length P, okay, this length is 3r, okay, and the particle returns to point P, then the initial speed of the particle is. So what we know, it will go here and from here it will be the projectile thrown from a height and it goes like there. So this distance, this d is 3r. I rate it as vc into root 2h by g. H fallen is 2r, 2r by g. So squaring both the sides, what I get now, 9r square is vc square into 4r by g. So what we get, vc square is 9gr by 4. Now applying energy conservation between a and c, vc square would be va square minus 2gh, h is again 2r. So what is va square? Va square would be equals to, what I can say, vc square plus 4gr, that what I can write. So what I have now, what I have is 9 by 4 plus 4 gr. So it is 1625 by 4 gr. So taking the root, it is root 5 by 2 gr. That is the initial speed b. I can go for option B. Next, this is the third one. The fourth one, what it says, the figure shows a vt graph of a particle going in a straight line starting from rest, the time after which particle returns to starting position. So to return to starting position means displacement is 0. And what you can say here, this area, first of all, this area, this is positive displacement. This is half into 20 into what we have, this is 25. So it comes out as 250 meters. So we are looking for extrapolating this, and when it becomes 250, so let's say it becomes at t, so this gap would be t minus 25. Here it becomes 20 to 0 in 5 seconds, so it is decreasing by 4, so acceleration is minus 4, so this height would be minus 4 minus, I can take it there, so write it 4 times t minus 25. So what is this area? I need this area to match this, so what I have, half t minus 25 into 4 times t minus 25 equals to 250. So doing this too, so this is 125, I can write here. So t minus 25 square is equal to 125. So t minus 25 is the root of 125. That is 11 point something. So 36 point something should be the answer. Go for option A. So just remember, don't write it as 25. 25 speed is 0, not the displacement is 0. Okay, that's a turning point for you. Next one. A conducting loop which is in the shape of a right angle isosceles triangle of height 10 cm is kept such that the 90-degree vertex is very close to an infinitely long conducting wire. The wire is electrically insulated from the loop. The hypotenuse of the triangle is parallel to the wire. Okay. The current in the triangular loop is in a counterclockwise direction and increased at a constant rate of this, the EMF induced in the wire. This will be solved by the concept of mutual inductance. So calculating M, it would be better assume current in the upper wire and find the flux through this. That is going to be more appropriate one. So how to find this? Let's say because it is 90 degree, I know this is 45, this is 45. If I go at a distance, let's say y here, and take a strip dy. So because this distance is y and this is isosceles, so it would be perpendicular. You can make out, and this would be bisector. So it is 45. This is 90. So this is also 45. So it means if this length is y, this length will also be y, and this length will be y. So this is strip length. This is strip length is 2y. So its area would be 2y dy. And if I calculate the flux through this, let me write it again. It is not visible properly. Yes, the flux would be B is mu naught I upon 2 pi y into the area. Area will be 2y into dy. That is what I can write. Okay. And this flux I write it as M times I. So I again get cancelled. The coefficient of mutual inductance M, that easily comes out as what if I do integration also. Sorry. So let me integrate it first. So I have cancelled. That would be equal to mu naught upon 2 pi into 2, so 2 also get cancelled. That would be equals to y is ultimately integrating it from 0 to 10, so it is 10 centimeter. That is what I am getting. So 10 centimeter is 1 by 10 meter, so it comes out in a standard unit as mu naught upon 10 pi. So if this is m, now going by the logic, E is equal to minus m di by dt, or let's say E2 is minus m di 1 by dt, so let it be 1, let it be 2. So m, you know what do you have, you had m as minus mu naught upon 10 pi di1 by dt. What is di1 by dt? Sorry, I should write it like this. Di1 by dt is 10, so it comes out as mu naught by pi. Minus plus is only for the sense, you can make out the direction from it, but the magnitude is going to be mu naught by pi. So you can do this. This question I think has come in advance, this on the same concept. I remember 1 or 2 years back. I'm not exactly sure, I have to check, but it has come. Two parallel plate air capacitors of same capacity are connected in series to a battery of EMFE. Then one of the capacitors is completely filled with dielectric of constant K, the change in effective capacitance. So we have done such questions before also. Previously the C naught I can say, because both were in series, that was equal to C by 2. Now the C will become what it becomes, the C times K times C upon C plus K times C. So it becomes K C upon 1 plus K. So the change that we need to remember would be C minus C naught, that would be equals to C common K upon 1 plus K, and this is minus 1 by 2. So what you have now, C 2k minus 1 minus k, this becomes 2 times 1 plus k. Okay, that is what I can write. And what it becomes, C, it would be k minus 1, 2 common here, 1 plus k or k plus 1, whatever you can write. So which option is coming out to be the appropriate one? See, all are looking like same. Find the right one. This is option A. Okay, next go for the seventh one. A, B, C, D are four particles with each of mass m lying on the vertices of a square of side A. They always move along a common circle with velocity v and a mutual gravitational force. Okay, find v so that they can always remain on vertices of a square. So what we have here, we have a circle here and they almost remain on a vertices of a square like this. So because they remain on vertices of a square, definitely they will be like this. This is the only arrangement I can think of. So what I can directly say, this length is equal to r. So diagonal length is what we have, 2r would be equals to root 2a. So a is equal to root 2r. That is what I can make the side length of the square. Now So if I look at any of the diagram, let's say because all particles are same, it will having attraction due to this, and due to this. I can make out if this force is F naught, this force is F naught, and you know this force is F naught by 2 because distance is root 2 times. So the net force becomes root 2 plus 1 by 2 into F naught, and F naught I can write as GM square upon what we had A square, and that should be equal to mv square by r. Mv square by r, and the radius would be the, what we can say, that is equal to r. I can directly make out. And what is a square? A square is 2r square. I can write, so put it in terms of a, that would be better. So put it r as a by root 2. So first of all, m and m get cancelled. What we have, 2 root 2 plus 1 upon 2 gm by a square, that is what we have, and that would be equal to r. I can write as a by root 2, that is root 2 v square by a. So a and a get cancelled. So the value of the v here comes out as 2 root 2 plus 1. This has become circle instead of 2. Let me write it again. 2 root 2 plus 1 upon 2 root 2, and this is gm upon a, and I take this complete root. So what I have now, if I have to do this which option is the appropriate one? Exactly, this is coming, so go for option A. So again, you must have done such question. Next, the RMS speed of oxygen molecules at certain temperature T on Kelvin scale is V. If the temperature is doubled when oxygen gas dissociated, the RMS speed becomes, we know V RMS is root 3 RT by M, because this has been doubled and this is dissociated, so mass will become half because of the whole. Now it is not O2, this is O, so the overall factor becomes double. So what we have, it will be 2 times. It is an easy one, perhaps the easiest of all till we have done till now. Now here, carbon monoxide is carried around closed cyclic process ABC, okay. BC is an isothermal. Gas absorbs 7,000 joule of heat as its temperature is raised from 300 to 1000 in going from A to B, okay. The quantity of heat ejected by the gas during the process C, okay. So I can make it out first. This A temperature is 300, this is 1000, and because it is isothermal, this will still be 1000, okay. So these temperatures I know. Now this is isothermal, this is isoparic, this is isochoric, okay. So first thing, the gas absorbs 7,000 joule of heat as its temperature is increased. So QAB is 7,000, and what I can make it out, that is equal to N CV into delta T, that was equals to 700. So N into CV I can make it out from here as 10. So the value of N into CV is 10. You can directly say NCV is 10. Now what happens in C2A? So C2A, if I have to write, I will write it as NCP delta T, which is a here minus 700. So it is minus NCP. Okay, so let me have it, let me write it only like this, 700 NCP, leave it like this. Okay, so this is negative. And what I have, what we need to calculate, this QC, okay, so we need to find out this NCP thing. So we can find out, because carbon monoxide we take it as diatomic, so what we can say, so NCV, CV was what I had, it was 5R by 2 was 10. So now what I have, this is 7R by 2, so it will become 700 into what we have, 7 by 2 into NR, and NR value I can write from there as 20 by 5. So what is now I am left with, this is 4, this is 2, 14. So minus 14 into 700, 14 sevens are, you know, is 98. So 9800 joule I should go for. So heat ejected. So the magnitude would be minus 9800 joules, that I can easily write from here. Next one. Uh, Let me have it. Okay. What it says, a ring of radius r is placed in the YZ plane, okay, and it carries a current I. The conducting wires which are used to supply the current to the ring can be assumed to be very long and placed as shown in the figure. Okay. The magnitude of the magnetic field at the center of the ring is. So here there are three things, three or four. What we have? Three, huh? 1, 2, 3. So first, due to ring. First, due to ring, I can say the field would be, you know, is mu naught I by 2r. And let me have the direction, please. So if I do this, it is coming towards me. That is I cap. So the due to the ring, it is mu naught I by 2r I cap, that you can directly write first of all. Next, what you can write because of this wire. So because of this wire, if you do that right hand rule or rule, whatever you do, this will be coming along minus z. So this wire, let's say b1, I can say this wire, this b1 would be, because it is semi infinite wire, it would be mu naught I by 4 pi r. You can directly say 1 is cos 0, 1 is cos 90, so you can make it out, and direction would be minus k cap. And due to b2 is what, this is here. If I do this, it would be along minus I cap, so it would be again mu naught I upon 4 pi r minus I cap. Okay, so we have this minus I cap. So now what we have now, what we have till now is these two are in opposite direction. This is perpendicular, so let me find the resultant of them. So the resultant of them will be mu naught I upon 2r. I can take as common. This would be 1 minus 2 pi. Okay, so this is along I cap and this is along k cap, so the resultant would be what I can say mu naught I by what I should take common. If the question is taking common, as in all option as pi is taking common, so I'll take, let's say, take 4 pi r common. So what I will have now, this would be 1 square plus b square. I can directly write this would be 1 square. This is completely taken, and because I have taken 2 pi extra, so that 2 pi minus 1 whole square, that is what I will be left with. So what I have, this as per this thing that I have written, so what it becomes 2 pi minus 1 ka whole square. So this would be what I can write. Let me write it again. 1 plus 4 pi square plus 1 minus 2 minus 4 pi, sorry. So 2 will be common and I will have it 2 pi square minus 2 pi plus 1. So this is option A, that is the most appropriate one. So it's just a lengthy one, not tough one. Be careful, be ready with the direction. Magnetic field is all about direction, that chapter. Two stones are thrown up simultaneously from the edge of a cliff with speed v and 2v. The relative position of the second stone with respect to the first varies with time till both strikes the ground. Now, till both of them are in air, we know A relative is 0. So relative velocity remains constant. So the position would be a straight line for sure. But because their speeds are with initial speeds, okay, and because you are not thrown up, because they are thrown up, both won't reach the ground simultaneously, and as soon as the first strikes and the second one left will have some relative acceleration, and then relative acceleration will remain constant till it comes to ground. So then because of the constant relative acceleration, it would be parabolic. So the graph would be first linear, then parabolic. You can directly make it out. You must have done such profiles. Next one, in the radioactive reaction, we are seeing successive emission is, so the first here Z is increasing by 1, A remains same, so that is beta minus. Here also the same thing, so beta minus. Here this decreases by 2, this by 4, this is alpha, so beta beta alpha. Which option? Okay, we have to look at the fourth one also. Here Z2, Z plus 1 and A minus 4, so again it is increasing, so it is beta minus. So what we have? Beta beta alpha beta. So go for option D, again not a tough one. You have seen such questions many times in your practice. Okay, next. 7 lithium target bombarded with a proton beam current of this magnitude for an hour to produce 7 beryllium of activity, this disintegration per second. If we assume that one radioactive nucleus of beryllium is produced by bombarding 1000 protons, then its half-life is closest to. So here they are produced at constant rate and are decaying. So standard equation dN by dt, the net rate of protection would be r minus lambda and n be the number at time t. And what is r? What we have 10 to the power minus 4. Okay, so first we have to find the number of protons. So number of protons in current would be I is equal to Ne, I should write. So the number would be I by E. I by E means 10 to the power minus 4 upon E. E is 1.6 into 10 to the power minus 19, and we know only one succeeds in 1000, so that divide by 1000 also. So this is the number of particles produced per second, that is the rate is this, minus lambda n. So lambda we are searching for, that is minus lambda n. Okay, so this is dn by dt, what we have till now. So this is the equation. If we, let's say, simplify this, this is 19 and 4, this is 15 and this goes 3, so that is 10 to the power, what I can write now, and this is 4 7 19 12, 10 to the power 12 upon 1.6 minus lambda, and that is what I have. Now disintegration rate would be this much, and this is given as for an hour. So after an hour, this is the disintegration. So let us first integrate it. What we'll have dn upon, and if I simplify this as, let's say, 10 upon 1.600 by 16, that comes out as 6.25. So dn upon what I was saying, it was 6.25 into 10 to the power 11 will become minus lambda, and that equals to dt. From 0 to 1 hour I should write, so let me write it as 1 hour or 3600 seconds, it's more appropriate thing. And this would be from 0 to n at time, what we can write at 3600, because for that lambda n I am given the value. So if I solve it, what will I will get minus 1 by lambda ln of 6.25 into 10 to the power 11 minus lambda n, and this would be 6.25 into 10 to the power 11, and this is equal to 3600 directly I can say. So now what we basically get now what we are getting is 6.25. So 1 minus lambda n upon 6.25 into 10 to the power minus 11 plus 11, sorry, not minus 11. Okay, what I have, take me this eraser. This is 10 to the power 11. That would be e to the power minus 3600 lambda. That is what I can write from here. So what is this value? This value, we need to find out what half-life now. Okay, so this is lambda n would be equals to 6.25 into 10 to the power 11 into 1 minus e to the power minus 3600 lambda. That is what I am getting. Now this value, this lambda n at this is given as 1.8 into 10 to the power 8. Putting at what we have, 1.8 into 10 to the power 8 equals 6.25 into 10 to the power 11, 1 minus e to the power minus 3600 lambda. Okay, so what we have now, if I do this calculation, what it becomes, doing this all, what I'm getting, 1 minus e to the power minus 3600 lambda, that is 1.8 upon 6.25 into 10 to the power minus 3. Okay, so this is going to be a good challenge for us, and now we have to find the value of this half life. So what is this half life now? So it's getting very lengthy calculation for me, but what I can do, I have to do, so 1 minus what I can write now, this would be very less. If I do, this would be, so now this is beyond doing, it would be really tough, so I'm taking the help. What is the calculated value? So from here you do, the lambda comes at 8 into 10 to the power minus 8 second per second, and then you can get this t half. It comes out as 100.26 days. So I've given up. I don't see any merit in doing this question in the examination hall. For me, leave it. It's too lengthy for to be done in the exam. It's better to do 3 questions of chemistry in that time. A particle performs linear SHM at a particular instant. The velocity of the particle is u and acceleration is alpha, both having the same direction. At another instant, it is v and acceleration is beta. The distance between between the two positions is both having the same direction. Okay, so let two positions have the displacements x1 and x2 respectively. So for first, what I can write, u square can be written as omega square a square minus x1 square, a assuming amplitude. Similarly, v square is omega square a square minus x2 square. Okay, so this is the first set of equation. Now second set of equation is magnitude of acceleration alpha would be omega square x1 and beta would be equal to omega square x2. So now what should I do? I need to find the distance. So distance is, let's say, magnitude of the displacement between two, that is x2 minus x1 I can write. So for that, it would be better if I subtract the above one. So what we will have now from there, u square minus v square is omega square common. Omega square a square will get cancelled out. So that will basically become x2 square minus x1 square. So from here I can get x2 plus x1, x2 minus x1. Okay, that is what I was looking for. That is u square minus v square. That is also given here. And from here, if I do, what I can do, let's say add them up. So alpha plus beta is omega square x1 plus x2. So putting it this x1 plus x2 as alpha plus beta by omega square, this get cancelled, that is x2 minus x1. So now this x2 minus x1, we get this, what we get this, u square minus v square upon alpha plus beta. So as per the option, is there any one? Yes, the first one looks like the appropriate one. So again, it's not that easy to get it in the first step. Now the way, next, spherical ball of diameter 1 centimeter, density, dropped gently in a large tank containing viscous liquid and coefficient of viscosity this. Okay, now the distance that the ball moves in 1 second after attaining terminal velocities. So first of all, you need to find out the terminal velocity, and you know that formula, 2 by 9 r square g rho of ball minus rho of fluid upon neta, that I remember. So what is r square? Half 0.5, that is 0.5 into 10 to the power minus 2 square. G is 10. Neta is 0.1. This is in SI unit, so 0.1 I can write it like this. And rho b minus rho f. So this is body is this is this, so that becomes 2 into 10 to the power 3. So now what we'll get now, 2 by 9, this will become 1 by 2, 1 by 4, and this 10 to the power minus 4, 10 to the power 3, and this, the all powers get cancelled, and this 10 remains and this 2 remains. Okay, you can do this. Now what I have now, 2 to 4, I get this, so what I get this 10 by 9. So in 1 second it will cover 10 by 9 meters. So this is simply the question to calculate the terminal speed, not a tough one I can say. Next, Given that the light velocity in quartz is this, okay, velocity means n is equal to 2, directly you can make it out. Velocity of light in glycerine, so if I do this, this one, this was for the quartz, this for this, it is 3 upon 9 by 4, so 12 by 9, 12 by 9 is 4 by 3, so n is equal to 4 by 3 for this glycerine. If a slab made of quartz is placed in front of an object kept in glycerine, then the shift of the object, so you know shift is t 1 minus, that is the mu relative that you typically write, so that mu relative will become what we can write, a mu relative I can directly write, n relative, or what I will say, n relative would be 2 upon 4 by 3, that is what you have, 6 by 4, so 3 by 2, so 1 minus 3 by 2, so it becomes 2 by 3, so this is t by 3 would be the shift, so shift t by 3, shift t by 3 is, that means 6 centimeter shift, that will be C. Okay, next. A sphere is rotating between two rough cylinder inclined walls as shown in figure. Okay, coefficient of friction between each wall and the sphere is 1 by 3. F1, F2 be the frictional forces at P and Q, then F1 by F2 is. Now from the sense of rotation, this point is going there, so this friction at this surface would be upward, and this friction at this surface is going to be downwards. Let's call it F1, let's call it F2. So this would be the normal from 1, this would be the normal from 2, and this would be the mg, that is the FBD. I think no other forces will be there, and because it is rotating, so it is not moving translationally, so forces must be balanced. So let's say first balancing the force along horizontal. So first of all, for this n1, the component of n1, because we know this angle is 30 degrees, so the component of n1 along this angle will be 30, so component of n1 along horizontal is towards left, that is equal to n1 sine 30 in left, and this f1 would be towards right, and this would be f1 cos 30. I am writing right in right, left in left. And this n2, n2 is coming, this is also towards left, and this angle is 60, so that would be n2 sine 60 I can write. And similarly this f2 is towards right, and I can write f2 cos 60, write this. So these are the forces, mg doesn't have any role, so this force must be equals. Now what we can have, n1 sine 30 is n1 by 2 plus f2 by 2 is equal to f1 root 3 by 2 plus n2 root 3 by 2, that I can write. Okay, so this is what I am getting. So this 2 2 2 2 2 2 2 get cancelled, and n1 plus f2 is what, mu times n2, that is 1 by 3 of n2, this is 1 by 3 of f1, sorry, n1 root 3, wait a minute, I'm getting it, yeah, this iPad seems to be hanging, no issue. So what we have, 1 by 3 n1 root 3 plus n2 root 3. Now what do you need? You need the ratio of f1 is to f2. Okay, so ratio of f1 is to f2. Let's get the value of n1 to n2, that would be f1 to f2, that is the same thing. So n1 to n2, if I do this, n1 by n2 dividing everything by n2 plus 1 by 3 is root 3 by 3 n1 by n2 plus n2 by plus root 3. Okay, so now what we get, n1 by n2, n1 by n2 here, what I will get, 1 minus 1 by root 3, that is equal to root 3 minus 1 by 3. So n1 by n2 is, from here what I can write, this comes out as root 3 into 3 root 3 minus 1 upon 3, and this would be root 3 minus 1. So this is a very interesting thing what I get now. I need to get it going by the options, and let's say this is root 3. Okay, so let me write it like this. This is 1 by root 3, so 3 root 3 minus 1, this would become root 3 into root 3, 3 minus 1. This is what I am getting, and if I simplify this, if you do this, it would be a tough task, but what I can see, it will come out to be 1 plus 4 root by 3. Try it out, it might come out like this. So again a tough one because of that simplification. The process was easy, but this last step is not that easy. Now in optical communication operating at 1200 nanometer, only 2% of the source frequency is available for TV transmission having a bandwidth of 5 megahertz. The number of TV channels is, so 2%. So first of all, what is the frequency of that carrier? You can have 1200 nanometer, that is 3 into 10 to the power 8 upon 1200 into 10 to the power minus 9. So what you have now, this is 7, so 10 to the power 15 into 1 by 4, or I can write it as 2.5 into 10 to the power 14 hertz. Now 2% is available, so 2% means 2 by 100 into 2.5 into 10 to the power 14, so that becomes 5 into 10 to the power 12 hertz. Now one require 505 megahertz, so number of channel will directly be what you can say 5 in 10 ki power 12 divided by 5 in 10 ki power 6. So 10 to the power 6, 10 to the power 6 is what you know is 1 million 10 lakh. That is what you can write it for. So this is 1 million you can directly say. So this is question number 18. Now the 19th one. What it says, rod of length is placed along x-axis. One of its end is at the origin. The rod has a non-uniform charge density. Okay, charge is given. Electric potential at P. So again the standard way, go at a distance x, take a dx, and what I can have. Okay, so there will be some mistake because if I take x, that x won't work like that x. So this is going to be not an easy one now. The integration is going to be tough for me, but let it be at x at dx. So what I can say, dq would be lambda dx, a by x dx, and if I write this dv at p, that would be k dq upon what I should write b plus x. So k, so it would be k upon b plus x, and dq is a by x dx. And now for that integrated x limit will go from 0 to L, and now you have to solve this. So if you are going to solve this Ka comes common. Now what we have, 1 upon x into p plus x dx. Now this is a question for the guys, you study maths, you know how to solve this kind of integration. So solve it out like you were doing. So solve it and you will get the result. But if I remember, it is taking b, multiplying and divide, and this will become 1 upon x minus 1 upon b plus x dx from 0 to L. So what you will have, Ka upon b, and if you go for this, 1 upon x is ln x, that would be ln L by 0. That is not going to be solvable. So I don't know how to do this, but this is how the question is given. For me, it's a leave now. I won't do it. So there's flaw in the solution. I don't agree with the way the solution is you doing. I'm leaving it out. Two rigid boxes containing different ideal gases are placed on a table. Box A contains 1 mole of nitrogen at T naught. B contains 1 mole of helium at 7 by 3 T naught. The boxes are then put into thermal contact with each other, and heat flows between them until the gases reach a common final temperature. Then the final temperature of the gases is okay. So what we are given, heat flows between them. There is a in thermal contact and nothing else is being done, so you can simply say one loses and one gains. So delta UA plus delta UB is going to be 0. So for the first gas, it is at the lower temperature, it will gain. So 1 mole nitrogen is 5R by 2, it will gain. So let's say T final minus T naught, and that is going to lose. That is what we have, 1 mole of helium, that is 3R by 2, that would be 7 T naught by 3 minus T final equals to 0. So this R by 2 goes 5TF minus 5T naught plus this becomes what it becomes, why this hanging, but let me do again. So it would be 7T naught minus 3TF, that is what I can say is 0. So what I have now, 2TF is equals to, what I have I'm getting is 2TF is equals to what it is becoming, 2T naught or minus 2T naught. I am getting it, and let me do it again. Now writing it, delta U is 1 into, because it is nitrogen 5R by 2, what I will write, T final minus T naught, here 1 into 3R by 2, and what I am going to write, T final minus 7T naught by 3, and that should be equal to 0. Okay, 7T naught by 3 equals to 0. Now again it is hanging, let me wait, yes. So what this R by 2 I take common, 5TF minus 5T naught plus 3TF minus 7T naught, that is what I am getting. So 8TF is equal to 12T naught, so T final is 3 by 2 T naught, and this is a very common question. I remember I teach this question similar, this has come somewhere, so this is available almost in all institute sheets. Now for what value of R the current in galvanometer is 0. Okay, so you need current in the galvanometer to be 0. That means no current flows here. So no current flows here. So we have no current is crossing it, so only this loop is effective, and you can say this is 2 volts. That is what I can say. This difference is 2 volt, they need it to be 0. This is 2, this is 12, so the drop is 10, so the current is 2 ampere. So 2 ampere means this drop is also for 2 ampere, it is 2 volt, so the resistance should be equals to 1 ohm. That is what I can make it out from the logic that I So it's an easy one. Next, 21st, after 21st it is 22. A silver sphere of radius 1 centimeter work function is suspended from insulating thread. Continuous illumination is photoelectrons are emitted. The sphere gets charged and acquires a potential. The maximum number of photoelectrons emitted from the sphere is, so again, you know, it will be emitted till the potential becomes a stopping potential. So first of all, 200 nanometer means photon energy is 6.2 eV. You can find out. So what we can say, the K max comes out as 1.5 eV. So the stopping potential is 1.5 volt you need to have. So for 1.5 volt you need to have KQ by RQ is N times E upon R. So the number of electron is this n would be 1.5 into radius, that is 10 to the power minus 2, k is 9 into 10 to the power 9, and e is 1.6 into 10 to the power minus 19. So it is 10 to the power minus 10 goes up 10 to the power 8 into what we have now, again hangs. Let me wait for it to come. Okay, 1.5 upon 14.4, that is what I can write. So a into 10 to the power z, where a is 1 to 10 and the value of z is. So what it is, let's say it is 15 upon 10 to the power 7, that will be coming. So go for option 7 you can do. Now I'm going very slowly so it doesn't hangs. 23rd. Two particles are simultaneously thrown from the top of two towers. The velocities are 2 and 14. Horizontal and vertical separation is 22 and 9. Okay. Then the minimum separation between the particles in the process of their motion in meters is okay. So now it is going this is the way. So let me first calculate the relative velocities first of all. So velocity of B with respect to A, or U I should write, not V, that is not the right way to write. So U of B with respect to A along x-axis would be let's say, or B with respect to A, I can write A with respect to B, I can write, that would be far better. Let it be at rest. So U of A with respect to B along x-axis, what I can write, 2 cos 45 minus minus will become plus 14 cos 45. So it is 16 cos 45. So you can have it as 16 by root 2 or 8 root 2. Okay. Now what you have in UAB along y direction, UAB along y direction would be equals to, what you will have, and this is 2 sine 45 minus 14 sine 45. So it comes out as minus 12 by root 2 or minus 6 root 2. So it is going down with respect to him. Then the minimum separation. Now you know A relative is 0. So first of all, let me draw it like this. This is 22, this is 9. And this velocity is, this is 8 root 2 here and 6 root 2 here. So it would be, let's say, and it will remain constant. So it would be like 10 theta if I do, it would be 3 by 4. So at 37 degree it is going like this. And if I calculate 9 by 22, that 9 by 22 would be, or 22 by 9, that would be more. So it would be going like this. So now minimum separation will be, so minimum separation will be somewhere here when this is perpendicular to this, or what I can say, this is perpendicular means this velocity and this point, it is like this. This is what we can say, this is the perpendicular distance or the minimum separation that I can search out for. So one thing is doing it that way, and the second thing is doing it the way that we usually do. So first of all, going by this basic logic, this was 9, this was 22. So if I go by this, because I calculated this angle as 10 theta, so because measured from vertical it would be 53 degree, I can make it out. So for 53 degree, if this is 9, so what we have 4 by 3, so this will be 12. This would be 12 meters, and it again, at this angle, this was 37, so this is still 37 degree. So what we have now, this angle will be 53 degree, and this distance you are knowing, this distance, what you are knowing, this distance is equal to 10 meters. So going by this is our minimum. So in that triangle, I'll redraw it like this. This is 90 degree, and this angle, this distance is what you had, 10 meters. This angle you are having as 53 degree. This is our minimum. So what I can write, cos 53 degree here would be equal to r minimum by 10. So r minimum would be 10 cos 53. Cos 53 is 3 by 5, so that comes out as 6 meters. So this is an interesting way of doing this, and this is the way we generally do this. The way given in your solution is good, that is based on differentiation. You can do by that also. Next one, the last two we have, 24th. Let me see what it is. A glass sphere having a refractive index 3 by 2 is having a small irregularity at the center. It is placed in a liquid of refractive index 4 by 3 such that the surface of a liquid is a distance r above the sphere where r is 20 centimeter. Okay. Now is radius of the sphere. If the irregularity is viewed from above, then what is the distance from the center where I will observe the irregularity? So now this is again when someone from above looks, first the ray goes from here to here and then from there to what we say air. So first of all, for the glass to uh, again this auto shape, let me remove it. So for this glass to water, I can say applying that n2 minus n1 result. So 4 by 3 upon, let's say v1, I should write minus 3 by 2, and this distance I can write it as minus r, or small r. I write a capital R, that's one and the same thing. That would be 4 by 3 minus 3 by 2, and this would also be minus r for sure. You can directly call it. So this is 4 by 3 minus 3 by 2, not r. This is 3 by 2. So now what you get now? So 4 by 3 v1 plus 3 by 2 r becomes what it becomes. It becomes 4 by 3 minus 3 by 2, that becomes 8 minus 9, that is minus 1 by 6, I can say. Okay, 4 8 is 8, minus 1 by 6 r, that is what I can write. So what it becomes now, so 4 by 3 v1 is minus 1 by 6 r minus 3 by 2 r. So taking LCM, this is 6 r, this would be minus 1 and this would be minus 9. So what it becomes, minus 5 by 3 r. So this is 4 by 3 v1. So 3 3 goes, so v1 comes out as what v comes out as, it comes out as what it is, 5 r by 4, that is r by 5 or 5 r by 4. It comes out as minus 3 by 2 r minus 10 by 6 r 5 by 3, so it is minus 4 r by 5. That is what we are getting. Now for water to air, and this distance is minus 4r by 5, it would be there 4r by 5 plus r, so this initial u becomes minus 9r by 5. So what I will write, n2 is 1 by v minus, what we'll have, we will have it as 4 by 3 upon what I can write it as 9r by 5 with minus sign. 1 minus 4 by 3, this is infinite, so no meaning. So directly what I can say, 1 by v is go there, that will become 9 negative 5 4s are 20 upon 27r, that is what I'm getting. So v is minus 27r by 20, or I can write it as minus 1.35r, that is what I can have. So this is 1.35 r, means this is 1.35 from here. So from the center, ideally this distance should be 2r, so the gap is 0.65 r, that is what I can make out, and the radius is 20. So 0.65 into 20, this comes out as 13 centimeter shift, I can write. So answer is going to be 13. So it's again a good one, lengthy one, you can say. You have to be careful, otherwise you can do mistake. Last one, when the forward bias voltage is changed from this to this, current changes forward bias, and this is an easy one. Resistance is delta V by delta I. This is the question I'm liking. So 0.6 to 0.7, 0.1. This is 10 milliampere, 10 into 10 to the power minus 3. So what we'll have as 10 ohms. This is one of the easiest one. In the last, this paper was not easy. Thanks for watching. Keep sharing.